Hi everyone, good day. I am Mboma Mary, and I'm here to talk about DevOps with Azure. But before we go on, I'd like to introduce myself. So I am a program manager, I'm also a student at the University of Lagos studying geophysics. And driven by the need to create an impact and provide value, I and my friends started a non-profit or a startup called ARETS, which aims to educate mostly children in the use of Microsoft Office tools. I'm also interested in writing, community projects, volunteering, and I'm actively working towards becoming a DevOps engineer. So to the talk of today, DevOps is fast becoming a household name as teams seek to better improve the products they release to customers. So I implore us to join me as I walk us through the concept upon which DevOps is built and highlight the tools provided by Azure to ensure that teams not only deliver products on time, but can guarantee that their products are of high quality. So the first thing, let's look at DevOps. So what exactly is DevOps? So DevOps is a practice which encourages the formation of teams, which consists of developers, testers, operation managers, and generally people who have a direct role to play in software development. So instead of having these people in different silos work separately, we bring them all together in a team. So why do we do that? To detect bugs earlier, to measure our team's progress, ability to adapt to the market and meet the actual needs of our users, faster deployment to production, and ability to recover quickly from build failures. So the thing is, when you have all these different people working together as a team, the flow of information will be quicker and faster. So if there's any break at any point in time in your deployment, anyone who is in charge will get notified quickly and can fix that. So let's look at software development life cycle. So software development goes through a series of phases, and each phase is built one on top of the other. Now let's look at the planning phase. Excuse me. So what happens in the planning phase? The teams define the features of the applications to be built. So DevOps teams make provisions for tracking bugs, creating backlogs, managing Agile, managing software with Scrum. They also create ways of visualizing progress and workflows by making use of dashboards, taking into consideration intricate details which are concerned with the software creation. They also draft out well-defined tasks to be carried out and make the workflow visible. Then the next phase is the development phase. So what happens here? This phase involves everything code. So from writing to testing to implementation and to building of code such that it can be deployed in any environment. So DevOps teams seek to deliver quality software rapidly and without compromise by implementing automated continuous testing and deployment of code. Then the next phase is the delivery phase. So what happens here? We deploy applications to the production environment in a consistent and reliable way. By automating these processes, we make our delivery system scalable, controllable, and repeatable. Thus, DevOps teams can deliver software frequently with ease and confidence. Then the next phase is the operations phase. So this involves maintaining, monitoring, and troubleshooting the application while it is in production. So everything that happens when our code is in production takes place in the operations phase. So DevOps teams work to ensure that the system is highly reliable, available, and has a near zero downtime, while ensuring that the security of the application is not tampered with. They also seek to identify and solve issues with the applications or systems before the user does by implementing chaos engineering and keeping logs. Now let's look at the DevOps culture. So people play an important role in implementing these DevOps principles. And most times we always have teams transitioning to DevOps. So it's very important to consider the DevOps culture when you're introducing it to your team. So the first thing is collaboration, visibility, and alignment. So for teams to collaborate, they have to be visible to one another. That is to share the DevOps processes, priorities, and consent. And they also need to align their tasks to fulfill a common goal by agreeing on how to measure successes and how best to achieve set goals. So the next characteristic of the DevOps culture is a shift in scope and accountability. So here we encourage teams to take responsibility and become more involved in software development lifecycle. So an example, sorry, for example, the developers become accountable for innovation and quality of software in the develop phase, and also to the performance and stability which their changes bring in the operate phase. So you can see here that we clearly define when people take responsibility for the tasks they do. The next characteristics is shifts in scope. Shorter release cycles. So what do we mean by shorter release cycles? We release software in short cycles. So by doing this, DevOps teams remain agile. This practice helps teams quickly identify and react to customer needs and competition. Also, planning and risk management become easier since the progress is incremental. And last but not the least, to have continuous learning. So DevOps environment supports continuous learning from mistakes and breaks in production. Having a growth mindset is key in any organization because then people know that there is no guilt tripping when a system fails. They will be encouraged to put their best foot forward. Also, DevOps is a journey and there's always room for improvement. So the next thing we'll look at are DevOps practices. So what are DevOps practices? These are features or procedures which DevOps teams inculcate in their software development life cycles. So the first one we'll be looking at is continuous integration and continuous delivery. So continuous integration, or CI, encourages the frequent pushing of code to the main branch of the source code repository. The codes, whenever they are pushed, have to pass an automated test before being merged to the main branch to ensure its stability. Then CD, which is continuous deployment, the frequent deployment of code to production environments. By automating this process, reduce the issues that might occur upon deployment and encourage more frequent updates. So by merging the two processes of continuous integration and continuous delivery, we encourage our engineers or developers to push code out in small chunks. So by doing this, it will be easier for us to detect bugs. And if there's any need for us to change something, it will be done quicker also. So the second DevOps practice we'll look at is the use of version control software. So version control software such as GitHub are used to track changes made to the code base, making it impossible for multiple developers to collaborate in authoring code. Using version control software, it is possible to handle conflicts, merge changes that are made to the same file, and roll back changes to earlier states. DevOps teams make use of this software because development teams are able to share code-related work among their members and store all the code easily. And also for continuous integration and infrastructure as code, version control software plays an important role. So the next thing we'll look at is Agile software development. So this is a method of software development which encourages team collaboration, collection of user feedback, and ability to adapt to changes by making the release cycle short. So here, Agile teams follow the process of getting customer feedback, learning and adapting their products to better suit their customers. Also, Kanban and Scrum are frameworks which are associated with Agile. The next thing we look at is infrastructure as code, which is sometimes referred to as programmable or software-defined infrastructure. They stem from the concept of programming scripts, which are used to automate IT processes. So it is the management of infrastructure, such as network, VM, load balancers, and connection topology in a descriptive model using the same version control software used for the source code. So an example of infrastructure as code tool is Terraform, which can be used to set up environments which we want to deploy our code to. So another advantage of using infrastructure as code tools are you can easily build up and tear down your environments. Sorry. Configuration management. This encompasses the technical and administrative activities concerned with the creation, maintenance, controlled change, and quality control of the scope of work. So using configuration management tools, teams roll out changes in a controlled and systematic way, reducing the risks of modifying any of the system's configuration. This is used together with the IAC, which is infrastructure as code, making system definition and configuration easy to templatize and automate, thus helping teams operate complex environments at scale. Configuration management can be used to maintain OS configuration files, preventive maintenance, and predictive maintenance. They will also look at continuous monitoring. This entails having full real-time visibility into the performance and health of the entire application stack, from the underlying infrastructure running the application to the higher level software components. This can be achieved by actively collecting telemetry and metadata. And what are these telemetry and metadata? Logs which are collected from various parts of the system, setting alerts for predefined conditions which warrant attention from an operator. DevOps teams set actionable, meaningful alerts and collect rich telemetry so as to be able to draw insights from vast amounts of data, which helps the team to mitigate issues in real time and also learn of ways to improve the application in future developments. So the next phase to look at is DevOps. Is it DevOps? What's the mistake? So it's the Azure DevOps tools. So what are the Azure DevOps tools that we'll be looking at? We have a host of them. So we'll start with GitHub. So what is GitHub? So GitHub is a version control software which is used for collaboration among teams. It also includes features for building, testing, tracking issues, and creating custom workflows in repository. It also comes in handy in the practice of CI/CD as it integrates with tools such as Travis CI, Circle CI, Jenkins, and a whole host of other CI/CD tools. Also, GitHub integrates with Azure DevOps, and they are used by organizations which adopt the DevOps practice. So the next tool we'll look at is the Azure Pipeline. So Azure Pipeline is a cloud service used to build and test codes and makes it available to your teammates. It integrates with version control systems such as GitHub and Azure Repo. It also employs CI/CD in consistently testing, building, and making deployments on any platform. Also, it maintains a consistent environment to run your application codes in. The next is the Azure Boards. Teams employ the Azure Boards to aid in visualizing the progress of their work by using Kanban boards, backlogs, team dashboards, and so on. Also, you can connect your GitHub repo to Azure Boards and link commits and PRs to work items. The next we'll look at is Azure Monitor. Teams use this to get a full insight and understanding of their app's metrics, such as availability and network. When problems arise, Azure Monitor helps you find the cause in shorter times and sort the data to show what's most important to you. The next is the Visual Studio. So Visual Studio is an IDE which is designed for cloud solutions. With it, you can develop, debug, and monitor your cloud apps locally. Then the last tool we'll be looking at is the Azure Kubernetes service. So this service helps us ship containerized apps faster and operate them more easily using a fully managed Kubernetes service. It also offers a serverless Kubernetes, an inbuilt CI/CD environment, and enterprise-grade security and governance. So this diagram shows us a workflow using DevOps tools. So the engineer builds his code on Visual Studio, then pushes it to the Azure repo, which passes through the pipelines, and then goes through a series of Azure products such as the Dev Test Lab, the virtual machines. So all these are tools which can be used by an engineer when making use of DevOps to build a product to be pushed out to production. So how can you get started using Azure as your cloud service provider? You have to sign into a portal and assign it to your account on the Azure portal via the portal.azure.com. You click on the sidebar icon on the left and select all services and then search for DevOps. You create an organization, invite your teammates, and begin to enjoy. You begin your DevOps journey. So for further inquiries, further readings, you can check out these links which are here. I believe you have any questions. So thank you for your time.